I'm sorry, like it got disconnected. Actually, my device's charge went, so it died. So as I'm mentioning, that we have to fix ourselves to certain group. In this case, let's say carbonyl is not present, aldehyde or ketone is not present here, because we have to stick with certain group in order to do some calculation. So let's say in this case, OH group is present. So if that's the case, we have OH, that means 18 plus 1, that's 17, sorry, not 18, 17. So this is the mass for, so far what we have found. We have 4 carbon atoms, like what we are sure. We are sure that this singlet is for OH, fine. And this like 4 is for the number of carbon atoms. So that's how much we know. So that means C4 we know we might have 1 oxygen, we might have, remember, we might have, we're not sure so far, but that's what we are assuming. We have 1 oxygen. So C4, we have 1 oxygen. We need to find the number of hydrogen. So that means 74 minus this mass. What should we get? We should get 9. That means there's a possibility that there's H9. So C4H9O is a possibility where we are assuming that we have an alcohol group. That means one of the carbon has an alcohol group. We're assuming. Remember, I'm not seeing the solution right now. I'm just assuming this could be a possibility. Now, after assuming, we will see if they resemble or not. This way, things are easier. If you assume, then things are easier to understand and things are easier to get. Oftentimes, it is not easier, but most of the time, it is easier to understand by observing at first that, okay, these are the molecules we have. So let's say we do have a CH group. So if that's the case, let's say this is our desired component. Okay, this is our desired component. And we have, let's say, the OH group here. Now we need 4 carbon atoms. Okay, we need 4 carbon atoms. Now, how do we do that? For this carbons, adjacent carbon is this. It has a like single hydrogen, that means a doublet here. So doublet, 2 doublets are for this each of them. But remember, we cannot have this like them here. Otherwise, we won't get like 4 environments. One is for this one, obviously. Another for this one. Another for this one. But we cannot have this one. But we need 4 hydrogen atoms, 4 carbon atoms. I know I made things complex here, but bear with me. So we do have an alcohol group, fine. We need in total 9 hydrogens. 1 hydrogen we have found. Second hydrogen hydrogen is not this one. Like excluding this, we need 9 more hydrogens. So is it possible that if we place 3 hydrogens over here with 6 and 7, that's not possible. We need 1 more hydrogen. How can we deal with that one? Let's see. If that's the case, we can sort of deal with this portion. Let's say this is our CH3 and this is our OH. Can it be the possibility? Then we have identical groups, fine. For identical groups, we have 1 environment, okay. For both of them, we will get, let's say, 1 environment, fine. We are getting, let's say, for this CH3 groups, we get this environment. We are assuming we get this environment, 1 environment. Then we have another environment over here, which is second environment. Then we have third environment and a fourth environment. Yes, that's what represents. Because one of the environment, if we have, let's say, this CH3 and stuff, that if we have a unique group here, then how many environments we'd have? 5 environments. But here we have what? 4 environments. We can see 1, 2, 3, 4. But see, if this CH3 and this CH3, they were unique from each other, they're different. That means this would have been 1 environment, this would have been second environment, then there's third, fourth, and OH has unique itself environment, 1 single. That means 5th environment. But we have only 4 environments. That means this is a possibility. I'm not saying this is exactly correct, but this is a possibility. Let's see how many hydrogens do we have here. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, we have 9 hydrogens here, excluding this OH. We have 4 carbons, 1 oxygen here. Oh, this oxygen, this oxygen with hydrogen was here. Okay, I forgot this. This oxygen with hydrogen was here. Because we were considering what? The mass of this entire thing. So oxygen is 16, hydrogen is 17. My hydrogen is 1. So 17. So it means C4OH and 9 hydrogen. So the molecular formula might be C4H10O. Let's see if that's the case. For this CH3 group, let's see, we have the environment, this CH, which has doublet, that means 1 hydrogen, yes. And same goes for here, like this will give us a similar thing. So considering one of them is fine. We'd consider this one, let's say. We don't need to consider that one. Then OH is this one, fine. This is OH. This is a CH3. This is actually for 2 CH3, isn't it? 2 CH3. Now, what about this doublet? See, there we have a CH2 whose environment is what? This CH again. That means we can say this CH2 or this CH2OH, this entire region's environment is what? This CH group, that means a doublet. That means this is for whom? CH2OH part. Okay? And this multiplate. Now, whose multiplate is this? Can you assume? Let's see if you can assume or not. Try to assume by yourself. See the structure. It is for this one. Why? Because see, this carbon has how many environments? This is another one environment, this is another environment, and this is another environment. That means in total, 1, 2, 3, 4, 5, 6, 7, 8. 8 hydrogens are here. That means 8 plus 1. There should be a 9 peaks here. There should be 9 peaks here. That means that's an environment for this carbon hydrogen. Now, let's see if like what we find so far, is it true or not? Let's go to the data booklet. Just a minute. Let me get the data booklet. So this is our data booklet. I hope you can see it now. So from here, what we can observe is this data booklet says we did saw CH3 group. So CH3 group's environment was in between this region, isn't it? But we got a doublet there. Yes, that's for CH3. We got 2 CH3 here, 2 CH3 here. Then about OH, we got a OH over here. So we got a OH there, which was in between. This was in between, let's say, 1 or something. We could say it was like 0. We can say directly 0.9 because it was really close to 0. So 0.9 we can assume. Then this one was in between, like greater than 2. So let's say 2.2. 2.2 was in this between region. And then we had, what else? We had a CH group. Now the CH group, before finding the CH group, we had what? CH2OH. CH2OH. Now for that portion, CH2OH, we had CH2OH. Is it here anywhere? No, not here. CH2O or CH2O is also fine. Is it here? CH2O. CH2O. Yes, exactly. See, here we have a region. So this is a CH2O. That means for alcohol. So remember I told, so this is the portion for CH2O. So this is 3.8 we get from our like information. Remember the last duplet, the duplet towards the at the very left, that was because of this CH2OH, and its corresponding adjacent carbon had 1 hydrogen, and there were like 2 more carbons there. But this was the case, isn't it? So that's the CH2O. See, if you assume, then things starts to get easier for you. Like once you have like thought of, okay, this could be a possible molecule. If in case things are not similar, just eliminate those portions which does not resemble. Okay, things will be much more easier for in that case. Now, coming back to the blackboard, let's finalize our information here. Let's set our information here. We have what? We have found we have 4 carbons, 10 hydrogen, 1 oxygen. Now, the molecular formula possibility was this one. C, 2 hydrogen, 3 hydrogen, CH2OH. Okay. Now they're asking you to find 4 isomer of itself. Okay. Now, remember, all of them must have 1, 2, 3, 4. Yeah, all of them must have 5 environments. Okay, all of them must have a 5 environment variable. Let me see. Is there 5 environment variable? Wait a minute. 1, 2, 3. No, not necessarily 5 environment. You have to just draw 5 as isomer of itself. Okay, you don't need 5 environments. Just draw 5 isomers of itself. So this was the one molecule. Another could be the simplest one, the very simplest one. This was one. Okay, then another could be. Remember, you can't repeat. Okay, this is OH. This is, it's a CH3. Then let's say, like, we cannot have this one here. Okay, this was very like this. We cannot have place this one over here. Now, in this case, let's say one such could be here. C, C, C. We have 3 carbons and 1 alcohol here. Yes, another could be, what could be another possibility? Is there any possibility? Yeah, this alcohol could be in some other group. So let's say, oh no, that cannot be the case. If that's the case, then we are just repeating itself. What else could be here? Let's see. We have that one there. Oh yeah, we can have the alcohol misplaced. Let's say the same initial molecule, initial structure. Okay, and we have, let's say, the alcohol here. So this and this are isomer of each other. You can also get another isomer over here, which is also possible. Just placing the hydrogen alcohol in some other position. Like there could be a lot of isomers. This is one possibility. Another possibility could be, let's say, on this case, let's say, no, not that one. Let's say, yeah, this one. Let's say here we have C, and let's say here we have OH group. Okay, so many possibilities could be there. Or again, this could also be over here as well. So in that case, this will be the situation. OH, we have this. Okay, so this could be a situation. Actually, we're repeating ourselves. So this is not a, this is actually repeated by this one. So this is not an isomer anymore. This one, this is also repeated by this one. So this is not an isomer anymore. So yeah, these are the possible isomers so far. Okay, so we have got 5 possible isomers. 1, 2, 3, 4, 5. Another one is this one. So total 6 isomers. This is the main one which we found with 4 environments. Now, moving on to next part, we have to actually distinguish which portion is representing which part. So we would say 0.9 to 1.0 is because of CH3. Okay, then we have what? A multiplate. You can say multiplate at which region? In between, that was multiplate. Let's say we mark it as 1.8. Okay, so 1.8. That was for which group? That was for our this CH, like this initial group, like this CHR group, isn't it? Or you can say this portion, this CHR means this is the CH group, and the rest of them are what? The R group. Okay, so this was the scenario, let's say. So this is the multiplate CHR group. R represents that portion. Then we have singlet, which is 2.5, let's say. That was OH. And finally, we have, let's say, 3.4 or 3.8, whichever we find. 3.4, let's give, since here in my case 3.4 is given. That was for what? CH2O group, isn't it? The CH2O had, I mean, the alcohol CH2O, this CH2O had adjacent carbon, this one, whose environment was what? 1 hydrogen, that means doublet. So, got it? This was the scenario how we solved the question. Now, let's move on to the next example. Let's say we have a molecule P here. When it is oxidized, this is oxidation, we get some molecule of CXH6O. Finally, we get some molecule M. Now, it's given this P is an alcohol. Okay, it is given. And M is to M plus 1 ratio is given as what? 4.5 is to 0.15. Now, using this information, and one more information they are supposed to be given is the absorption values or the absorption chart. Let's say this is 0, 1, 2, 3, 4, 5, 6. And we had triplet in this region. We had most probable quartet in this region. quartet in this region. Okay, then we have over here between 3 and 4, we have again a triplet here, and finally we have a singlet somewhere near 5. Okay, this is actually given as like counts per, like some unit of counts per minute most probably. I'm not sure what is this unit represent, but some value is represented by here. Okay, most probably in the data booklet is given. Let's see if it is given or not. That is chemical shift value. This is known as chemical shift value. Okay, this is known as chemical shift value. Okay, now another curve is okay. That was for P. This was P. Okay, the other chart is given for the information of M. We have because between 0, 2, 4, 6, 8. This is 10. This is 12. Okay. Now we have a singlet near to 12. We have a quartet in this region and a singlet, triplet in this region. Okay. So that's what is defined here. Yeah. So that's basically it. Now that's also counts per minute. Now using this information, we have to find what is P and what is M. Okay. Now we have the M:M+1 ratio. Let's at first find the number of carbon atoms, number of C atoms. You can pause the video, try it by yourself. It's completely fine to see how far you can get. Okay. Then when you get stuck, you can pause there. I mean, you can stop there and like pause the video. Okay. So here we have 100 divided by 1.1 into 0.15 divided by 4.5. Since we have to reciprocate this value, we get 3. That means there is 3 carbon atoms. There should be 3 carbon atoms. But see, here we have 1, 2, 3, 4. 4 environments. That means, obviously, if P was said as what? As an alcohol. And if this is a carbon of 3 carbon, just assuming, let's say we have 3 carbon and 1 alcohol. See, 1 environment, 2nd environment, 3rd environment, 4th environment. So 4 environments are here. Now you might say this CH2, CH2, they are unique with each other. How they are having 2 different environments. See, for this CH2, towards right it has a CH2, towards its left it has a CH3. Okay, fine. And for this CH2, towards its left we have a CH2, but towards its right we have a OH. That means different, fully different environment. So there are 2 different environments. So this is one possibility. Okay. Now this is just assumed one. Don't go with this one. Just assuming this could be a possibility. And they're saying we are doing some oxidation. Sorry, where? Yeah, oxidation. We're getting CXH6O. After oxidation, C, we know alcohol is oxidized to get what? If this is a primary alcohol, okay, let's do some other thing. Let's see if this is a primary alcohol, there could be a secondary alcohol, isn't it? Secondary alcohol could also be oxidized. If that's the case, OH. Let's see how many environments are here. Here we have 1 environment, but see, this CH3 and this CH3, they're identical. Why? They're bonded with same like carbon atom. That means 1 identical, like both are identical. So 1 environment, this 2nd environment, 3rd environment. That means this secondary alcohol is not possible, isn't it? Because we have 4 different environments. So this one is not possible. Also remember, there could be a tertiary alcohol, but we are not going to deal with tertiary in this case. Why? Because tertiary alcohols cannot be oxidized, but here we are undergoing oxidation reaction. So things are easier for us in this case. They have mentioned it should be oxidized to get this molecule. That means this is the primary alcohol. And how do you know primary alcohol is not secondary? Because we cannot form like 4 environments with secondary in this case. Now when this is oxidized, what do we get? We can get either aldehyde or carboxylic acid, since this is a primary alcohol. So if we get aldehyde, that means OH. sorry, that means CHO group, that means this group. And that's what they have represented. See, we didn't get 2 oxygen here. That means in this case, no carboxylic acid was formed. But in the following up position, yes, there could be a carboxylic acid produced. But let's see if this is the case. If that's the case, how many environments do we get? We get 1, 2, and here's 3. So 3 environment, okay, fine. But this is further oxidized. What do we get? We get a carboxylic acid with 1, 2, and 3 environments. See if we have 3 environments or not. Yes, we have 1, 2, 3. 3 environments are there. That means we are so far good to go. That means this could be M, this could be P. We're not sure so far. This is P, I mean, this is M, and that's P. Okay. Now for P, let's see which portion is for which part. Here we have a triplet. Now let's consider it for this carbon. Why we are considering this carbon? See, if you consider this carbon, it has a triplet to the nearby, like to its nearby portion. Here, if it is CH2, then it has a triplet. That means this could be a possibility. Also, if this is this CH2, it has also this CH2 as its neighbor. So this could be a possibility, it's a triplet. But see here, we have 2 triplets. That means, yes, we are in the right track. That means here should be 2 triplets, one for this carbon, another for this carbon. Like this carbon's neighbor is this triplet, okay? Now, coming back to our information, since this is alcohol, the alcohol, this peak is for whom? The alcohol. This peak should be for alcohol. Now, for whom is this portion? Obviously for CH3, because so far we have seen in data booklet, we have memorized so far that this is for CH3s, like neighboring CH2 group. So that means this is for the CH3 group, because it does not have any other groups with it. But this portion, which is more than 3 and less than 4, which could be somewhere around 3.8, let's say, if we go back to the data booklet, we would observe that this portion, this is in between the region 3.2 to 4. That means 3.8 is actually in that region, just CH2O. That means if we go back to our graph, this actually could represent CH2O's environment, this CH2. That means what? There's a possibility that this is actually for the CH2's environment, CH2, okay? CH2's environment has a triplet, fine. Finally, we have what? There's a multiplate. Actually, this is not 4, this should be multiplate. There should be some other as well, there should be 5. Now, how? This could be 5 or 6. There should be actually 6, but consider this as a multiplate. Maybe I have drawn, yeah, this is a 6 carbon, like 6 hydrogen. Yeah. I miss, like I drew it like in the wrong way, but that's the case. Then what could be, like, how do we define this one? See this one, if this carbon is the, like, this is the only carbon left behind, isn't it? Its neighbor is what? This CH3 and this CH2. They have each, like, both have how many total? In total hydrogen? 4. Sorry, 5. 1, 2, 3, 4, 5. 5 hydrogens. 5 plus 1 is what? 6. That means here this multiplied for this CH2 group. Okay. Now let's come for our this carboxylic acid part, if it resembles or not. There's a peak more than 11, less than 12, which we do know so far observing data booklet that this is for the carboxylic acid. That means this is for COOH group. Now for this region, let's consider for this one. What is this? We also know this is a possibility that this is a CH3 group, since it does not have any other like bonded atoms. So this CH3's environment is this CH2. That means this could be for the CH3 group. CH3's environment is what? CH2, which is triplet, because 2 hydrogen has 3 peaks. Finally, this CH2's environment is which one? This CH3. See, we have 4 peaks. That means 3 plus 1, so 4 quartet. So this is a possibility for CH2. Or we can say that this is actually for CH2 double bond O. CH2 double bond O. How? Let's get back to our data booklet. Because since this is not in the region of, let's say, this portion, like this is more than this portion, if we get back to the data booklet, those region, those particles or those species or groups which are in this region, those are what? Those does not have any bond with any special type of atom. But those who are more than this region, more than 1.7 or more than 2, are bonded with some special group, maybe oxygen, maybe nitrogen. Okay, so let's see. Over here, we have a CH2C double bond O, which is in between 2.2 and 3.0. Let's get back to our blackboard and see. Here we have what? This CH2C double bond O group, and its neighbor is CH3, and it resembles that this is in 2.2 region. So got it? That this is actually, sorry, C double bond O. Yeah. Let me clearly draw it. Basically CH2C double bond O. Okay, so that's the region, because its environment is which one? CH3. And for CH3, we are getting this quartet. I think now little by little things are getting easier for you to understand what is happening actually. Okay, so we got to know secondary alcohol is not possible, tertiary alcohol is not possible, primary alcohol is possible, and aldehyde and primary alcohol is the way to go. Okay, moving on to our next example. Next example is given as, they have mentioned the molecule for which this HNMR is represented. There we have, let's say, 0, 1, 2, 3, 4, 5, 6. Let's say it goes on. And we are given that this is HNMR graph of, let's say, C4H10O. Okay. And they have also given that there is one peak over here, another peak over here. And they have said this peak represents 9 hydrogen, this peak represents 1 hydrogen. Now, why is that? That means for the like, how do I explain this? This one is for someone who has like 9 hydrogen towards his environment, and this one has someone who has just 1 hydrogen towards, like, let's say, the possible environments. Just give me a second to see if I'm correct or wrong. Okay, so still nothing so for sure I'm here, but let's see. Let's try to do this. They mentioned that the structure is C4H10O. That means it represents that this should be an alcohol. If that's the case, let's see if this is the molecule. So it's 4 carbon, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogen, 1 oxygen, fine. So far good. But there we have how many environments? 2 environments. Forget about the singlets here, or how many peaks here, but consider here 2 environments, isn't it? But how many environments do we have here? 1, 2, 3, 4, 5 environments. Not possible. Totally not possible. Fine. Let's go for the other isomer. Let's see. We have to do some trial and error in this case. Okay. So this is OH, or simply over there we have the OH here. Okay. Now, if that's the case, this is one environment. This is another environment. This is another. So this is also not possible. There we have total 5 environments. Let's make something, like, let's make things easier for us right now. Let's have some groups now. So let's say we have 1, 2, 3, 4, 5, 6, 7. We need one more alcohol. Yeah, we need one more here. So let's say this is the case. How many environments do we have? 1 here, 1, 2, 2 here, another here, because these are identical. So 1, 2, 3 here, 4 here. That means 4 environments, not possible. There we have 5, here we have 4, here we have 5 here as well. So not possible. Is there anything else we're leaving behind? Yes, one another one could will also be found. So how many environments do we have? For like these are identical, isn't it? For each of them, we have one environment, just single environment, isn't it? We have just a single environment because for each of them they are identical. We have another over here we can consider, but observe your complete like focus here. Should we consider this carbon for an environment? If yes, then why yes? If no, then why no? Remember, it cannot be a yes. Why? Because this HNMR is done on whom? Depending on how many like if the carbon has a hydrogen, then we can do it like we can have its environment. That means this carbon does not have any environment. I mean, does not have any hydrogen, so we cannot consider it as its environment. Like we cannot find the environment with respect to like let's say we cannot have any environment with respect to this portion, but we can have this complete portion's environment. This complete portion environment is which one? OH. Okay. So that means we have over here one environment, like this as the entire one environment, and this is another environment. So in total, we have how many environments here? Wait, yeah, 2 possible environments. Fine, that's completely fine. Now let's see, let's like make sure if things are correct here or not. For one of them, we have to either see for this CH3 or this CH3 or this CH3, like how many peaks are there to its adjacent carbon. So this carbon's adjacent carbon is this one. It does not have any hydrogen. That means 0 hydrogen. But number of peaks is what? Number of PEAKS peaks is equals to what? N plus 1. N is 0 plus 1, which is what? 1. That means the adjacent carbon should have how many hydrogen? 1 hydrogen, isn't it? The adjacent carbon should have 1 hydrogen, isn't it? Same goes for this one. Same goes for this one. That means total of 3 CH3 has the same environment of 1 peak. Now, 3 CH3 means what? 3 is a 9 hydrogen, isn't it? That means this here represents the 9 of the hydrogen has same chemical environment where the corresponding carbon has, or the adjacent carbon has no hydrogen. That means only 1 peak. Okay. And this peak over here is for whom? The second environment, which is for our alcohol group that contains our 1 hydrogen. So that's what they represented here. Got it? So that means our final structure is here CH3, here CH3, here CH3, and here are OH. Okay. In total, we have 2 environments. So this CH3 has peak somewhere 1.2, let's say, which is singlet. Okay. And the OH has a peak near to, let's say, 2.1. That's it. That's also a singlet. Okay. Got it? So that's how we solve these things. So that peak was for the methyl, like 3 methyl groups. And this peak is for what? The OH group. Okay. I hope things are getting a bit easier now since things are now more explanatory. I also myself actually didn't revise the core concepts before like coming to give the lectures. This is just my thought process with time, revising things like as I'm taking the classes, like things I'm recalling, like how this could be or what this could be. Also remember, in my student time, like when I was a A-level candidate, so I also faced certain difficulties and certain things I couldn't also understand. But while teaching now, things are getting clear right now, which was not clear back then. So yes, don't worry, things will like be easy, like become easier for you. Let me help you out with another example, which I will be giving you as a homework. So your duty will be to solve them. Okay, so this is, let's say, at 0, 1, 2, 3, 4, 5. Okay, now they're saying this is an HNMR for liquid A. This is a liquid A. Okay, and we have a group over here, which is represented by 3, that means 3 like hydrogen, somewhat what it means, but you have to find it out. Then we have something at this 2, which also says 3, and somewhat of a quartet here, which represents 2. Okay. Now m is to m plus 1 is given as 5.1 is to 0.22. Okay. And m peak at mass per electron, that's given as 88. That means the ion's molecular mass, let's say. So molecular ion peak, you can say molecular ion peak. So they can give the information in different way. So you have to find now what could be this molecule. Let me help it out. Using this, try to find out the number of carbon atoms. Then use this value, like these concepts, to see how many environments are there. Then resemble, if the number of carbon atoms, the environment resemble with each other, then try to make sense, okay, which groups could be possibility for which group, like which group of atoms could be a possibility for this environment, then which one for this one, which for this for, okay. Remember, this position represents that specific carbon we are dealing with, and this number of peaks represents its adjacent carbon having the number of hydrogen. Okay, so 2 things are involved here. One is me, my position is this one, and the peak number represents my environment. My environment or my neighbor has, let's say, how many family members or how many child. So that sort of thing. Now, finally, use this value m peak to find, let's say, the number of maybe hydrogen atom, or if any other atoms you are not sure of, use this value to find that number, like that values. Let's say previously we used this value to find the number of hydrogen atoms there. Okay, so yes, use it wisely, and hope to see you in the next class. Take care. Assalamu alaikum.